people will say they like to see us doing machine work, so we'll do a little bit of machine work here too. Looks like an engine block. I didn't taste it. It smells like an engine block when you cut it because of the cast iron. And 351 Windsor. And we'll explain a little more here as we go along what that's about. The first thing I wanted to do, I'm just kind of out here in the shop and bouncing a little bit of video out. You notice how there's a gap down at the bottom, and the way I'm fixturing this up. One thing, using the head bolt holes, because clamping onto stuff on an engine block a lot of times directly is not that great, but they've got good places. They've got bell housings, they've got heads. Always remember, same on gearboxes, other stuff, but always remember the bolt holes that are in the part you're working on. Sometimes that can save you for bolting it down. In this case, I get to use 3 of the bolt holes, 3 of the head holes. I could actually, I can't, these ones here don't line up. I could use these, but they get a little bit in my way because of my stick out. What I'm trying to do is mill some flat spots here. So 3 bolts, it's enough. I did the one side already. But one of the big things I want to mention here is, as you're doing this, and it will basically suck up to this plate, but it's better to not be fighting gravity. We come in here, and if we lift the block up, then when I tighten it, instead of it having to lift, it can settle down. So that makes it a little nicer as far as knowing that it's going to match with the angle plate instead of catching a little below and wedging. And the other side should be good enough. I could bar it and play with that, but it's all rocking together. There's also engine blocks. Your surface is not always square. There's some of them that are off. 409s, 348s on your Chevys, your early big blocks, they were at an angle. And all their ideas for that, that's history and not mine. Anyway, so you've got flat surfaces. You also have, many times, you're using your main bores for lining stuff up. That's also a real common one. A lot of your automotive tools, you'll have a shaft that goes through here, and you're doing that just for lining up your engine bores. It'll be a shaft that it goes onto, and it tilts 90 degrees one way or the other. And I don't know what other kind of fixturing's in there. I've never actually used one of the machines. I've worked on them, as far as wiring and stuff, but I've never actually ran one of them. So what we're doing here is we are milling. And when I did this, the first side, of course, I had to get the spacing to match the bolt hole pattern on the head. And the middle one is free, but I wanted to get the 2 widest bolt holes, and I'd already figured the spacing was enough. There's only 5 in a row, twice there. And we could do this by power, but I did it both ways, and I found it actually just easier to do this by hand feeding rather than chasing it around with power. And I'm going to go ahead and lock the quill, and I will bring the head down. And when we get done milling this, and we'll show you what it's about. So I have got to bring the table in. I'm trying to take the minimum that I can here and get a cleanup. They're not all the same from one to the other castings. They just wanted them cleaned up. look on, that looks like it should clean up. I always forget about that. Bert puts the camera in my way when I'm doing something I need to see, which is good for what he's doing. That's his job. Put the camera in my way. If he didn't do that, then it would be only me that was seeing. Okay, we'll blow that off. And it looks like I did not go enough. No, I can already tell without trying. I need to go a little bit more here. This part needs to be narrower for it to work right. You can see right here where the shank of the cutter is fairly close too, so I got to watch that along with the end. I didn't have reverse lockout in. That's reverse. Okay, that was forward lockout. Go that way. That's what happens when you don't run your machines every day. Other people playing with them. And Austin could have done this. but he didn't really want to. We'd never done one before. And it's better if we're going to have problems that I have the problems. And I don't think we're going to do another one. So it's not really like we needed the learning experience. We could do one. And I don't think it's going to pay. I think we're going to charge them less than what it's worth for our time-wise. You could do really good on a job like this if you had, run the head up. You could do really good on a job like this if you had a CNC set up to do all the stuff you need, grab the block, and you could have guaranteed customers that would bring you at least 10 blocks every day, which will never happen. And that's why Blueprint Engines has such a better business plan, where they get a hold of castings and build stuff from new castings, and you don't have to worry about whether somebody brings you enough old castings that need work. So there, now that fits down there, and what it's about is roller lifter conversions. So this block originally was for flat tappets that have to rotate around to distribute wear. These ones have to not rotate so that the roller can stay in line. And the little bridge, now there's a different style of lifters they've got that have an H bridge, they call it, that goes in between the two. And that was all of the old ones. When the manufacturers, Ford and Chevy and them, they went to this style when they started doing them in the mass production vehicles. Not quite as demanding and functional, but this block was before it was made for that. The newer blocks that are made for that are also taller. They make this area here taller so that it's got more support for the lifters. These lifters are only for this application. They're a little bit longer in the flat part on the top to make up for less area here. And they're also, the cam is ground down to an even smaller base circle than what you normally would. So this is sort of a specialty setup so that you don't have to buy the H bridge lifters. This is comp cams. I see these, and part of why I would bring it out the information about these, because when I get into something, even if we're probably not going to do it again, I like to find out what's going on. And what happens, the specs on this, they tell you drilling and tapping holes to hold the hold downs for these, because these hold the lifters in line. There's a little tab there. There's a sheet metal piece that holds all of those in. And yeah. Is it in the box yet? Maybe it's smaller than I remembered. It is in the box yet. Okay, it was smaller than I was thinking. So this goes down in the valley. And it sits on top of those and holds them all in place. So we have to drill and tap the two holes in here also for them. And now there's a discussion. When it was given to me, I was told not to worry about drilling through here. Whatever I hit, just go through the casting, it's fine. There's a discussion in the paperwork and other people that talk about hitting your cam bearing. And I believe, I haven't looked at it yet, but I think we do go through where the cam bearing goes. But since they're putting in new cam bearings, doing this engine, it wouldn't hurt anything. It would be if you were installing this in a vehicle, but it'd be pretty silly to install this in a vehicle and you know, drilling and tapping, even if you can get it all done. Your extra contamination and possibilities of having bad cam bearings while you're putting in a new cam, because you can't run the cam that was in it. You're going to have a different cam. It just seems like too much to do for an in-the-vehicle situation. And if you're pulling it out of the vehicle, you really should go ahead and pull the cam bearings out. And anyway, what I see a lot of people, the instructions just say to put these in. They don't fit. They would have been way crooked. They might have sort of worked. A lot of people are taking grinders and they're grinding in the engine block here. And that can work. you know, you grind in. This doesn't have to. There's a fair amount of clearance. If this is within 10, 15 thousandths of being square, it would be okay. Now, you got to do a good job to have it right, but you don't have to do a perfect job. It's going to be okay. So I can see somebody doing it with just a grinder. Ignoring it, I think you're looking for catastrophe myself. According to the instruction sheet, they don't say anything about it. You're just supposed to bolt them on, put your 2 bolt holes in. I disagree as far as just a general mechanical concept. It should be flattish. It doesn't have to be perfect, but it should be flattish. And machining it off works. I thought for a little bit about making tool, either just for doing this job even, or for the fact of doing them for other people and selling the tool even. I thought I can make a tool easy enough, it'll come in here and put a spot face on both of these. And that's not a problem making the tool, but I don't know that there would be enough sales because most of the people that are real serious about this, once they find out you have to start going through this, they just go and buy the H-bridge lifters, is what a lot of them are doing, at least from what I see on the internet. But this should work. I mean, this will work out. He's got all these pieces, and it came here, and we'll get done with it, and we'll, like I say, I'll know in advance. I should have known, but it's so easy when somebody comes here and says, I just need this, you know, and you're like, oh yeah, we can. And then you get to thinking about, oh yeah, now I got to hold it. I got to have the right stick out with the long end mill, and it's not, yeah, you know, I mean, we can do it. We will get it done. But it's not the 15-minute job it looks like that you think you're going to get done in 2 hours. And if we were doing them all day long, you know, we'd get pretty good at these. Even doing them manually, we'd probably, if we had a pile of them here, we'd probably do a block in an hour and a half, I would guess. But doing just one, no. And I don't honestly see it being worth, yeah, what it's going to take. But anyway, thought you might be interested in that too, on that comp cams. That's a 351. There was some other, of course it fits the 302 versions also, but there's more of the 302s in roller cam around blocks. There was another, if you see, search for these anyway, I'm thinking it was some kind of some of the Chevys, but I'm not sure. I think it was the Chevy. I think it was the earlier Chevrolet blocks. I think they used this same basic kit. Might be a different sheet metal piece. Might be the same. But I think, because Chevrolet and Ford use the same lifters as far as the basic, the old lifters. They're the same diameter. A lot of this stuff was the same. Pontiac, whole bunch of them. I say Ford, and I believe. I know there's several that are the same. I think Ford and Chevy. Could be that I'm thinking of Chevy and Chrysler, could have been in all 3 of them. I don't know. Pontiac I know is the same as Chevy too, but there's a bunch of them because lifters are paying to build, and it was cheaper to just have somebody else build them, and once they start building a lifter this size, well, it works. Why change it? Why make something weird for our engine? And that is something that engineers really should be doing today. We have got too many parts. We don't need an engineer to sit down at a drawing board and draw another new bolt. There's bins over there with bolts that were invented way back before the 50s. They will work for 90% of what you're doing. Don't invent another bolt. Don't invent another flange. There's standard flanges. If you need to slightly change, but look at the amount of parts for a given thing today that don't interchange with anything else. It is stupid. That's one of the biggest problems why we don't have replacement parts for equipment. We used to have, you know, go back to 1930, there were probably 10 fuel pumps. You know, in the 50s, there were probably 20, and we had 40 of them in the 70s when I was doing this stuff. Of those 40, you could swap the parts internally between most of them. You know, they were still mostly the same fuel pump with a different arm on them. They weren't that different. We don't need another bolt, another cover, another whatever it is that makes you feel good because you could sign your name on the drawing. See how many parts you can reutilize that already exist. Now, don't take an obscure part, take one that's been used a whole bunch, and before it dies, let's make some more of them. That's why there's one rifle that a lot of people did not like when it came out, an AR-15. The reason why people really love AR-15s today is because of the interchangeability of the parts. And all of the suppliers, this person makes 22 million triggers, and somebody else makes 22 million barrels, and another person over here welds them all together. And, you know, uniformity. It's a stellar engineering idea that was by necessity back in the 1800s. They had to start standardizing things. They had a hard time with it. They got it down pretty good by about 1915. Then they kind of wavered back and forth to around 1970. Then we got CNCs, and somebody said, "Ooh! All we got to do is tell the guy down in the shop to change stuff, and he could change it. So let's make another one that's different." It's nice to be able to make changes, make it a little different when you want to, but don't make it different just because you can. It would be nice to be able to interchange the parts, and then we could have the man with the nice CNC make a much more intricate, better frame that all of the standard parts fit on, because he'll have the time to do it, instead of making a bolt that's the same functionally as the one made in 1895.